Hello everybody, welcome back. Today we're going to be looking at section 11.3, which is on arithmetic mean and geometric mean. The word mean in math, as of right now up to this point, is the same thing as saying, hey, find the average. So going back to maybe like say Algebra 1, or maybe when you heard the first time heard the word, let's say we have the numbers 7 and then also the number 13. And I want to know what is the mean or what is the average in between the two. Well, from kind of like inspection, I think you can probably say that number is going to be 10 because if you take 7 and then plus 13 and then divide it by 2, that's going to get you that 10 then. So that is going to be our mean then. Now, this in turn in relation to what we're doing is really the arithmetic mean, because if you look at it carefully, you're adding 3 to get to the 10 and then you're adding 3 in order to get to the 13. So that's why it's arithmetic. So let's be a little bit more specific now when we say the word mean in math, because well, there are actually two types. There's the arithmetic mean, which is what we talked about and what you've been doing so far. And now we're going to go ahead and also introduce the geometric mean, which we're going to look at in just a little bit. So let's take a look at the first example. What I would like to do is I want to find 3 arithmetic mean, AM for short, that is between the numbers 4 and negative 80. So if I were to write out the meaning of all of this, it means that we have 4, the number, and then we have 3 numbers in between, just as such, right? And we don't know what they are. And then finally, we end up with the negative 80 at the very end. I want to find what those 3 numbers are so that when I put them all together, it'll give me an arithmetic sequence then. So hence, that's why it's called arithmetic mean, because it's like the numbers in between that you're adding consistently. Okay, since we're referring to an arithmetic mean, then I best bet we have to put down the arithmetic sequence equation. So let's write on the side. T of n is equal to T of 1 plus D multiplied by n minus 1. Now, from a glance, we know that T of 1 is equal to 4. There are a total of 5 terms. We don't know what D is, so that's probably what we're going to have to find out. But like we were saying earlier, we have 5 terms, so that means that n should then be equal to 5. And T of 5 specifically is going to be then equal to that negative 80 at the very end. So if we were to put it all together, right, remember T of 1 once again is equal to 4, then we have the following equation. Negative 80 is equal to 4 and then plus D multiplied by 5 minus 1. I want to solve for what D is, which is supposed to represent the difference that you're supposed to add or subtract in order to get from one term to the next. So subtract 4 from both sides, you get negative 84 is equal to D multiplied by 4. And so it looks like D is equal to negative 21. So in context, then that means that I'm supposed to minus 21 each time to get from one term to the next. 4 minus 21, that's equal to negative 17. From negative 17, if I subtract 21, that is going to give me negative 38. If I subtract 21 once again, that's going to give me negative 59. And if I subtract if I subtract 21 again, that should give me that negative 80 then that I'm looking for. So those right there, that's going to be my answer then. Okay, so those are your 3 arithmetic mean. Now, in the case of a geometric mean, it's the same idea, but we're just referring to a geometric sequence then. So in the next problem, I want to find 2 geometric means between 135 and 5. So if we were to write it out just like before, I'm going to say 135 is the first term. There are 2 numbers that I'm looking for in between, so that when I multiply one from the other to get to the next, and when I get to the 4th term, that's going to give me 5 as an answer. So same as before, I'm going to go ahead and now reference the geometric sequence equation. T of n is equal to T of 1 multiplied by r to the power of n minus 1. And by the way, feel free anytime at any point in this video that you want to go ahead and pause and try this for yourself, just to see if you get the same answer as me, because, I like for you to, test yourself if you can. So, as such, we're going to go ahead and say the first term is going to be 135. The ratio we don't know, so that's a question mark. N is supposed to be equal to 4 because there are 4 terms, and T of 4 specifically, the 4th term, is equal to 5. So throwing all of that into the blender, we have now 5 is equal to 135 multiplied by r to the power of 4 minus 1. And we're supposed to solve for r, which is the ratio that we're multiplied to get to one term to the next. So first I'm going to go ahead and divide 5 by 135. Not exactly nice, but I do feel like it does come out to be somewhat okay. 1 over 27, if I'm looking at it correctly, because it's supposed to be 5 over 135, is equal to r to the third power. You don't have to use logarithm for this, hopefully not, because these numbers are somewhat nice and clean and you're not solving for an exponent. So if I take the cube root of both sides, then that means r is equal to 1/3. So same context as before. I'm going to go ahead and multiply by 1/3, or you can say divide by 3. So multiply by 1/3, that's going to give me, what is 1/3 of 135? That's equal to 45 if I correct. Then we're going to go ahead and say multiply by 1/3 of that, and that is going to give me 15. And if I multiply by 1/3, then yeah, 15 and 1/3 is going to give me 5 then. So in this one, those are going to be your answers then. For the last one over here, find 3 geometric means between 4 and 324. Now you might think to yourself, okay, well, it's not that different from the previous problem. It's just that it's probably a little bit bigger. But in turn, there is something very unique about this one, and that's why I want to go over it. So write it out once again, right? So we're going to go ahead and say 4, comma, question mark, comma, question mark, comma, question mark, and then we have 324. So same as before, we'll go ahead and refer to the geometric series sequence equation. So 324, which is supposed to be the fifth term in this case, is equal to the first term, so 4 multiplied by r to the power of 5 minus 1, because there are a total of 5 terms. Now watch what happens here that's making this unique. First we divide by 4, which is going to give us 81, is equal to r raised to the 4th power. And yeah, you're probably not thinking much of it because, oh, okay, well, if I look directly, take the 4th root, then that means that r is equal to 3, and then we're pretty much call it a day. But if you take it one step at a time, you'll realize something. First, if I take the square root of both sides just to kind of, show you what's happening, then that means we have the following. 9, because that's the square root of 81, is equal to r squared. Yeah, that's one part. Then from here, we can say that r is equal to 3, and then r is also equal to -3. So that tells me, hey, there are actually 2 geometric sequences that satisfies this condition. And this is the part that you're not going to like, because if I look at the way that we did, technically, if I take the square root of 81, right, because I'm taking the square root of r to the 4th, then that means that r squared is also equal to -9. And now going back to chapter 10, that tells me, we got now some imaginary numbers to deal with. So r can equal to 3i, or also r is equal to -3i. So let's go ahead and put them all together and show you how all of that nastiness works out. So let's go ahead and put this kind of like a little bit closer to the side and kind of grind it all out together then. So here we go. And finally, here we go. Okay. So in the first case, when r is equal to 3, that I guess is not too bad. So it's going to be 4, comma, multiply by 3, so that's going to be 12. Multiply by 3, that's going to be 36. Multiply by 3, that's going to be 108. And multiply by 3, that's your 324. Now, when r is equal to -3, I guess that's not too bad because you're just going to make what you have and alternate them. So 4, -12. 36, and then -108, and then positive 324. Same deal. When it comes to the imaginary part, when r is equal to 3i, this is where you have to be careful. 4, and then you multiply by 3i, you get 12i. Then if you multiply by 3i, and I'll write it right here, multiply by 3i, you are going to get 36i squared, which is then the same thing as -36. So that's actually going to be our middle term then, -36. And that's where things get a little funky. So -36 here. Then we're going to go ahead and multiply by another 3i. That's going to give us -108. And then there's an I right there. And then finally, if you multiply by 3i, that'll give you 324. And finally, for the last one, let's go ahead and change that last color. Let's go ahead and use black in this one, okay? So r is equal to -3i. We have 4, and then multiply by -3i, that's going to give us -12i. Then for the middle term, let's kind of write that out. Negative 12i multiplied by negative 3i. The negative cancels out, leaving us with 36i squared, which also gives us another negative 36. Okay, so that's going to go into there. Next, we take that and multiply by negative 3i. That'll give us a positive 108i. And finally, if we multiply by negative 3i again, that should give us the 324. So all four of these guys will satisfy all the conditions. And yes, we do need all four of these as solutions then. Whew, quite a bit of work. So just be very careful about that, okay? And I guess my question to you is, in what scenario will you have imaginaries in your geometric mean? Whereas in what scenarios will you have just positive or maybe just negative numbers in your geometric mean? I want you to look at the difference between number 2 and number 3. Figure out what is it that I'm asking that leads into each conclusion, okay? So that's something for you guys to kind of explore. Final kind of like challenge question, and this is again something I want to leave to you guys to try for yourself. I'm not going to completely answer the question. Is I want you to find a geometric sequence that contains t of 5 is equal to 12 and t of 7 is equal to 448. Now, again, just to give you a nudge, since this is a geometric sequence, right? I'm probably referring to the equation t of n is equal to t of 1 times r to the n minus 1. So this is probably where I'm going to go ahead and leave it for you guys to try. But if you want a small little hint, maybe I can give this to you. If I take this point right here and throw it into my geometric sequence equation, it's going to read 448 is equal to t of 1 times r to the 7 minus 1, which in turn is then the same thing as 6. Now take the other one and let's do the same thing. Throw that into your geometric sequence equation. You're going to get 112 is equal to t of 1 multiplied by r to the power of 5 minus 1, which if I clean that up is going to be to the power of 4. So I think that's probably a good enough hint as to where to go to figure out what t of 1 and r is equal to. If you'd like to give it a shot, go ahead and do so, by all means. All right, thank you so much for listening. Have a good day. Goodbye.